Hello all. Welcome to this video series in which my colleague Ananda Mondal and I, Akanksha Kurd, will be giving an outline of the project we conducted for the I606 Network Science course at IU. There are 5 videos in this series and we'll kickstart the series by giving a brief introduction to the topic and explaining our motivation to pursue this project. Throughout this course of network science, we have seen that the network approaches and methods have been used to study a large variety of real world systems like social interaction, transportation systems, genetic and protein interactions, etc. In each of these cases, there is a concrete understanding about what constitutes as the nodes and links in the network representation of the system. This understanding is either obvious from the system of the study or is driven by the available data and the process of interest. For example, in social systems, nodes can be the individuals or social media accounts, and links are the relationships between those individuals or the follower or followee connections. But what if I want to study financial systems with a network science perspective? In this case, the most common choice is the stock market network, where the choice of nodes is obvious as the companies. But what about the links? How do I connect two stocks? The intuitive answer to that is that you connect two stocks if they somehow behave similarly or show similar trends. The available data for stock markets is something called a time series, which shows the changes in stock prices with time and looks something like this. But based on this data, how do I know whether the two stocks are behaving similarly? How do I quantify the similarity in their behavior? That's where correlation comes in. The term correlation, for most people listening to this video, would mean a specific form of equation, but we are not there yet. In the most general sense, correlation is the process of establishing a relationship between two variables. Here specifically, we'll try to establish relationship between the time series of two stocks. All of these methods listed over here, which we'll be discussing in the next videos, look at the time series of two stocks and give out a number, which is called the correlation strength. In the topic of financial networks, after the stocks are selected, correlation strength is calculated for every pair of stocks. Following this, a pruning is done to keep only the necessary links, which are then used to generate the network. However, in this process, whether a link makes it to the network depends on whether the metric is successfully able to capture all the nuances between the time series of those two stocks. This made us think that what are these different metrics actually capturing, and more importantly, what is it that they cannot capture? Secondly, what is a good threshold? And how are these two factors affecting our representation and understanding of financial systems? In this project, we have tried exploring the answer to these questions by diving a little deeper into the correlation matrix and pruning algorithms commonly used in the analysis of financial systems. We'll be seeing more details in the following videos.